Welcome to this session for AP Computer Science Exam 2018 Free Response Question Review. Question 1. The question 1 is about reasoning of the simulation of a frog hopping in a straight line. So the frog will be hopping in a straight line, and then you try to determine whether it reached the goal or not. And then the frog attempts to hop to the goal line within a specified number of hops. The simulation is encapsulated in the following frog simulation class. And over here you have a frog simulation class, and then you have a private variable goal distance, that is the goal line you need to reach, and then there is a maximum hops, that is the number of hops that is allowed for you to hop. So if you don't reach the goal line within that many hops, you will be determined to have a failure for reaching the goal line. And also, it provides a function called hop distance, and this hop distance can go forward or backward. So if you end up to be behind your original point, then you will be determined as fail to reach the goal line as well. And also, if you try too many hops, then you will also be determined for not reaching the goal line. So there are a few rules that actually will determine whether you reach the goal line or not. So basically, you have two data fields, and these two data fields, you need to use the constructor to set them up with the proper initial value. And then you need to design the simulate function and another one called run simulations. So part A, write the simulate method, which is simulate the frog attempt to hop in a straight line to the goal line from the starting position of 0 with the maximum number of hops. So you can only be allowed to hop for so many times. And here are the successful conditions. Number 1, if you reach the goal line or pass the goal line, you are successfully passing it. Number 2, if you fail because you fall behind your original starting position, then you actually fail. And then if you pass the maximum number of hops allowed, then actually you also fail. So you have one successful condition, two failure conditions. The following example shows a declaration of a frog simulation object, and the goal distance is 24 inches, and the maximum number of hops is 5. So let's look at it. So basically, the constructor create a frog simulation object of 24, that's the goal line distance, and then you have the number of hops of 5 be allowed. And then you try to do simulation, and each one actually you do one simulation. And then if you have this, and then your final position is 24 and you pass it, because you have 5, 7, that's 12, minus 2, you are 10, and then plus 14, you reach 24, then the result of the simulate method will return true. So simulate for the others. And then for this one, you hop right with 4 and right with 2, then you are at the position 6. But you hop back by 8, then you fall back by minus 2, then actually this is a failure condition. And also, if you try 5, 4, 2, 4, 3, you end up with this one is actually, you finish up at the position 18, then you actually fail. So now, the part A need you to write the simulate function. And we just need to check whether you actually finish by negative check, or you finish by reaching goal, or you reach by the exceeding the maximum step allowed. So only the second one will return true, others will return false. So basically it's a for loop. So you started from the number of steps of 1 to less than maximum hops. So this one actually do the simulation for do the hopping for so many times, and then each time you increase your distance by hop distance. It may move forward or may move backward, that's fine. then you check the goal line. If it passes, then actually return true. If you fall behind the 0 position, your starting position, then you return false. So these are the two conditions you check. And if the loop finish, that's the condition that you fail by passing the number of the maximum hops that is allowed. So basically here you have a 3 condition checking of the boundary condition being implemented. Part B, write a simulation method which perform a given number of simulation and return a portion of simulation in which the frog successfully reach or pass the goal line. So basically, you need to run that simulation for example, like 400 times. So there is a parameter called int num. The int num is the number of the simulation you need to run. And then you collect the data for true or false. And then, for example, you have 100 successful try. Then you end up with the percentage successful rate of 0.25. So the nature of the problem is tally the successful simulation and calculate the ratio of such successful ratio. It's not actually difficult. So basically you set up a count variable and then you do so many simulation, the number of num steps, and then if you have a successful simulation, we increase the counter. And at the end, you actually need to divide that number of count by the total number of steps. Then you have the ratio of the successful rate. And you need to convert count into double in order to have the ratio in double value. So this one is not hard. And here is the frog simulation. And I implement this hop distance by mass random times 16. So you will generate a variable between 0 to 15. And if the distance actually is a multiple of 5, then I return the minus or negative value. If it is actually not a multiple of 5, then I will return the positive value. So this one actually gives you the percentage value, backward percentage of 20%. And then here is the simulation and non-simulation. And I have the simulation result of this. So let's go to my program to see how it works. So part 1, I have the frog simulation. So right here, I turn on the distance. Let's don't look at the part 2 because this one will make part 2 ugly, but that's wrong it. So actually you do 4, 4, 14, 4. So it's successful past the goal line. So let's run one more time. This time successful. One more time. Successful. One more. So this one go to backward and pass the original point, so it failed. Now let me turn down this distance. And that is wrong again. So as you can see, by a different simulation, I have the ratio of 0.46, 46% successful rate. Now let's go back to the slides. Question 2. The question 2 involves reasoning about pair of words. So we have a pair of words, and that is constructed in a class called word pair. And then you can get first, get second. That's fine. That's not difficult. And then we have a word pair list. So in this one has a relationship. So word pair list contain a array list of word pair. It's called all pairs. And then you have a constructor, that's a part A, and then you have number of matches. So let's look at the part A. So it wants you to write a constructor. So basically you will be given a array of certain number of the strings, and then you need to construct the relationship between each one. So you have 1 to 2, 1 to 3, and 3 to 1. I'm sorry, 3 to 2. So you have 3 relationships, but you don't need to, because it's unidirectional, so you actually just need to have 1 to 2, and 2 to 1 is considered to be the same relationship. Same for this one. And 3 of them, you actually will end up with 3 relation, and 4 of them, you end up with 6 relations. So this one actually is the K-method that I actually talk about. So that's actually, we will have, for 3 points, you have A, B, C, you have 1, 2, 3 relationship. 4 points, you have A, B, C, D, and you will have 1, 2, 3, 4, 5, 6. So it's actually a complete K-graph relationship. So how to generate it? Actually, if you took my course, you should be able to know that I have the intense review on this K-graph, and you just need to be able to write the partial traversal of 2D array in order to construct that. So it's a good example for K-graph problem and find all the permutation of the pairs. So here you create, first you need to create a array list body for the all pairs, and then you actually traverse through this partial array. So the traversal would be, for example, if you have 3 actually different word pair, you have 3 different word, you will need to, because the diagonal you are checking with the same one, so you have the 0 to 1 pair, and 0 to 2 pair, and 1 to 2 pair. So totally you have 3 pair, but you need to traverse the upper corner of your 2D traversal. So basically you started from I equals 0 to the I length minus 1, because the last row actually you don't traverse through it. And then you go column starting from I plus 1, because you started from here and then to the end of the row. So that's what we can do, and that's 2D traversal. And then by that 2D traversal, each time if there is some relationship, each time if there is some mutual relationship, you will add that pair into your word pair list, all pairs. So that will complete a K-graph, and those K-graph is recorded in your all pair array list. Now part B, you need to run the function called word pair list. So you will check the number of matches, and this one is actually easy. You just traverse through the 1D array list to check which one has the same value. It actually is repeating. So that actually is quite easy. So it actually is a 1D traversal, counting the number of the match paired in the all pairs word list. So you just need to traverse through the all pair array list, and then get first to match to check equality with the get second, and increase the counter if there is a match. So this one is quite easy. So here I have the part A for finding those pairs, and part B to have this more words, and the more word is described in the problem statement. The more word is described over here. The more word is described here as a 5 words array, and there is a 2 repeat. So basically, the number of matches we will find will be 2. So that's the number we got. Question 3. Question 3 is a string checker. So there's an interface called string checker, and we need to implement this string checker. And be careful, right here it has something hidden. They will require you to construct a code word checker constructor, and there's another constructor that needs you to pass the single parameter that specify the maximum and minimum length for default 60 or 20. So basically, you need to write a constructor, and right here you have, if you have this phi and a, so basically your string need to be between length of between 5 to 8, and then you will check cannot contain the star. And then this one, it will be false because you contain the $sign. I'm sorry, it's $sign. And then, or your code length is longer, it is not matching, or shorter, both of them will not be successful. So basically, you need to implement a class, and that class has the storing the maximum number of the character allowed in a string, and also the minimum one, and also the forbidden string that will make the word invalid. So we actually need to write a invalid function, and invalid function is also a logic and condition to make sure that everything is matching. So you need to overload the constructor, because the constructor has two versions. So basically, the class will need to implement the string checker, and then you specify the initial value or the minimum and maximum length of the string by 0 and integer max. But this actually will be overwritten by the 3-parameter constructor or 1-parameter constructor. And this 1-parameter constructor, you actually can write like this or like this, both work. And we have 3 data field, min, max, and no words, and no words is the forbidden words. So you actually will assign the forbidden words and the maximum string length and minimum string length. And then to check the validity, you pass one string in, and then check for the maximum and minimum length. If it's out of range, then you return false. And then if you contain the restricted words, then you will also be a false condition. Otherwise, you will return true. So it's a default true, exceptional false function, and this is the class to implement. And either way, for this one, either way will be fine. For code word checker, left or right, both are okay. And the isValid will have 3 different formats that you can write. I just list them over here. Question 4. This question is about the array of integers. So we have an array tester, and you actually will be given a 2D array, and then you need to be able to get the column. So this one is a column major traversal to get all the column content, and then assign them into one 1D array. And then you have the all value check-in to make sure that one array's value is also be in the second array. That's the have all values check-in. And that is not the one of the problem that you need to answer, but I have the implementation. And then there is a content duplicate in an array to make sure that it will return true if there is duplication in the array. If not, you contain false. And I mentioned before this in our class, this is also a K-graph application. So K-graph actually happened 2 times, but this one just don't need you to implement it. So K-graph, you have an array A, B, A, C, D. You check with the same array. So this one is a K-graph checking, but you don't need to check the diagonal part. You don't need to check the diagonal part. You just need to check this upper corner. Probably check with the upper corner, or you check with the lower corner. Either one. You just do the partial traversal. Either one will be fine. I'm sorry, this one should have 3 of them. And then you have 2 of them over here. I'm sorry. Okay, so that actually is what we need to do. And then it will check is Latin condition for a square, whether that's a Latin square or not. So now let's look at how to get a column. So to get a column, you basically just need to do traversal on 1D so that you get the whole thing out to a result. So that actually is not really too hard. So basically it's a 1D column traversal or column matrix traversal. Assign a value to a new array. So basically you set a new array with the number of rows for the 2D array, because that's the vertical traversal, and then you traverse through the vertical for each row item in the column C, and assign that to the result column and return that. That's not hard. Second one is Latin. In Latin, checking the following 3 conditions. The first row have no duplicate, so you just get the first row and then run the contain duplicate check, and it must return false to validate this. And second one, you actually check each row to make sure that every row has the value from the row 1. So it actually will call that has value function. Actually, let's look at it. This one will run this has all value function to make sure that one array's value is all contained by the other array. So that's the only function we need to run. And then for the column, same thing, you get columns of each column in the 2D array, and then you check with the first row to make sure that all the first row value is shown in each column. Okay, so let's look at it. It's Latin. So this one is actually Latin. Each one, actually the first row's value all happen on different row or different column, and that's the value we want to check. That's the 2D array we want to check. So here these two actually are the Latin square, and these are not. So let's look at the program, how to write the program. So it's a for loop and operation. If one condition doesn't match, you'll return false. So you need to check whether the row has duplication or not. If there's duplication, then you return false. And then you check whether every row has the content of all the items in the first row or not. Also, you check all the columns, whether they have the content from the row 0 or not. And then you need to implement 3 different logical rejection rules. So basically, the Q for part B will be you get the first row first, and then make sure that your first row don't have the duplication. And then you get each row, and that use that row to compare to the row 0, and make sure that all row 0's elements are all in row. If not, then you will return false. Similarly, you get all the columns, and if the columns has all the value in the row 0, then it will return true. Otherwise, it will return false. So the array tester are listed over here in Latin, and get column. These 2 functions will be returned in the exam. And here are the simulation results. The part A, I mentioned it already. And we are checking 5 different 2D array. And these 5 actually are these 5 different matrices. So the result will be the first 2 matrices will be true, others are false. Okay, thank you. Bye now.